All right, folks, it's 10 a.m., so we're going to go ahead and get started. Welcome back. Pushed up a few fixes to the class repo, so if you do get pull, you should have all of those just in case. We just fixed a small issue. Now, currently, we've been talking about something called views and how we could isolate all of our logic that has to do with what should this look like to the user into this thing called views, or into these view functions. Next thing that we're going to do is we're going to look and see if we can do that a little bit more with some of the model pieces of code. So from our quotes app, you can see that inside of my controller, I say connection.query, and then inside of this, I have to then say, okay, then once you've gotten all of that to the database, then you can send all that information, etc. I don't want my route to have to think about, hey, have a connection to the database and use that directly. Where this route is saying, yeah, that SQL connection I made earlier, make sure that you have that, and then make sure you have all of these references to the database. This is sort of all over the place. If something's wrong with my database, I have to look all over my server and then look at the specific route. It's not ideal. So we're going to look a little bit at how we can start doing that with models. And then we're going to start looking at how we can specifically use a library called Sequelize to make that process easier for us. So let's look at number 12, model example. Now, model example isn't a web server. It's just trying to show us how we might isolate stuff. If we look at server.js, we can see there's no express anywhere. There's not even the HTTP module. We just have something called DB. And DB is part of a models folder. And there's an index. And guess what? The index is working a lot like it does with the views folder. The difference is we have a buyer and a pet there. And the buyer and the pet aren't functions, they're objects, and they're meant to represent the buyer's table and the pet's table. In fact, if we look inside of this folder labeled DB, we can see that there is a schema here for the pets DB. If we look in seeds.sql, we can see that we are inserting a couple of different values. Let's go ahead and add use pets to the top of that just so that it knows. There we go. So I've moved this into a folder that says, hey, if you need to make your DB, this is how you do it. You have these two files. Next, I've moved my connection into a specific file. What I do is, here's my connection credentials. I'll need to put in my password, MySQL, the connection is like this. And then we say connection.connect, and then we export the connection. So this file exports a live connection to the database. So if anyone wants to use the database, they can, but we don't want to rely on other pieces of the program using that database connection directly. So what we do is we've got these models. Let's start out by looking at pets. So pet is an object that makes it easy for us to work with it. Let's look at our usage code. In server.js, I say select an order, and I take the animal and the price, and I order it by the price, and I just get back a object that represents what this is. So I just called the db.pet select an order, take the animal price, console.log that out, and then console.log out the results. In fact, let's go ahead and run this program. Require models.js. That shouldn't be the case. I'll push that up in just a second. I think Visual Studio Code has been adding JS's on me. .buyer. Find who has most pets. There we go. man. Let's see. Let's double check something real quick. We'll double check the rest of those. Let me comment that out. We'll work with the other two real quick. All right. So we've got connected as ID 110, pets by price, pets named Rachel, and we can kind of see each one of the different pieces that we got. So let's look at that. So we have select where for pets named Rachel specifically, and we've just returned a new promise, and we either resolve that data or reject that data. So I just know that I'm going to get a promise back. Some of the things that I'm selecting is, hey, I want to see everything where the column equals a certain value. So where the column, the double question marks, equals the value, the single question mark, lets me pick a column a lot more arbitrarily than this one. So if that works, I resolve, it works, goes on just fine. Otherwise, I reject the promise. Select and order works similarly. If I look at select and order, I say, hey, I want these animal names and animal prices. I pass it an array of columns that I want to work with. And if we look inside of pet, it just says, oh, here's the columns that you want to select, and what would you like to order them by? So select question mark from pets and order by question mark. So the columns I want to select and the column I want to order by. So you can pass in an array to just say, hey, here's the columns I want to see. And
double
the order
question mark, double question marks mean it can take in an array or like choose from multiple?
What it means is it can work with the structure. So you won't be working with values. You can use things like the table name or column name directly instead of just values. So the double question marks are a little bit less safe than the single question marks. And they mean a slightly different thing. So that's why they're differentiated like that. As in essence, if you put something in a question mark, you're going to have something in quotes as a value or like a number or something that you're looking for. Cool. Now, some of the time, you might also have some buyer looks pretty much the exact same. Now, there's some repetition here, but I could do like, hey, let's write one real quick. I could say like, hey, based off of my buyers, if I look at my database here, or if I look at what my schema is, I could just get the buyer name. So I could say select where buyer name equals one of our buyers, let's say Jane. So I could come over here if I want to write that query, and I could say db.buyer.select where, and then I would say where the buyer name is equal to Jane. And then take my resulting buyer, console.log, buyers named Jane, there should just be one, and then console.table, the result. So I don't need to know the SQL as much. I need to know what pieces are there. But I don't necessarily need to know all the SQL commands. Now, if let's look at buyer.js here. So let's look at find out who has the most pets. So we're going to select buyers, that should be buyer name, count star as count, from buyers left join pets, on pets that buyer ID is equal to buyer ID, group by buyer name, group by buyers.buyer name, order by count, descending, limit 1. So this will give me back just who has the most. So let's save those changes. Let's go over to server.js, uncomment this one out. So this is another reason you might do this. You might figure out, hey, I figured out this exact SQL query I want to use. It's kind of complex. So what I'm going to do is hide that from the rest of the program. If you need to know who has the most at any given time, you just find out who has the most pets. And I would like to know the buyer name, the buyer ID, any of this. Or actually, do we use any of that? I don't think we do. Yeah, we can just ignore that. So let's go to this
Can you
one.
pass anything into that function?
No, you don't need to. I don't know why that's that way. There we go. So find out who has the most pets. Let's go ahead and stop this, start it up again. I had that query working just fine earlier. Let's go ahead and look at our schema really quick. Yeah, the ID, and then we've got the buyer ID.
Would it be buyer's ID? I think it's missing S.
Yeah, thank you. Let's try that again. There we go. So who has the most? Jane has the most with 3 in that particular case. So this returns just a single entity, which is why when we use console.table, it just lists out all the properties one after another, rather than members of an array that happen to match up with that. So Jane has 3, and if we look at our seed data, makes sense. We've got 3 with an ID of 2, and that happens to be Jane. So when we're making these models, we want to hide some of our complexity. We want to not have to worry about select star from buyers where anything. We go, hey, select where. Here's the column I want. Here's the value I want. You could even have grouped these together as an object or something like this. We could do select and order, and you could imagine having a lot of different ones like this. Now, the implementation of this particular model isn't awesome. We can see some problems with it where we see, oh, you're repeating yourself a lot. Like this function is basically identical on, except for the word buyers and the word pets, right? There's a lot of repetition there. Same thing with select and order. Find who has most pets, that's different, sure, but there's going to be a lot of repetition. So we're actually going to be working with a library that does a lot of that for us, but it's going to be doing basically this same idea in it. So with that, I want to go ahead and move on to, and let me push up these changes really quick, but we're going to go ahead and make sure that we're moving on to the next section where we look at sequelize, and I just wanted to kind of introduce the idea of that, the same way that we're doing that with, let's see, commit this here. But the same way that we sort of abstracted away our view code from the rest of the program, we want to do that with our models and our interactions with the database. We just want to have a model and it gives us data. We don't particularly care where it's stored or how or other things like that. Cool. So let's go look at number 14, full stack activities. So inside of 0, I want to kind of talk about what we're building towards, which is this idea of a pattern called Model View Controller, or just MVC for short. And you'll see it referenced a lot out there. So this is starting to divide up the responsibilities of what to do. So whenever we make a request we're going to be talking to something called the controller. And the controller's responsibilities are all about orchestrating the specific pieces. It's all about making sure things happen. The view and the model, we have some other ideas about. We've talked about the view a little bit. The view is responsible for just what it looks like. It doesn't make any changes. It doesn't modify anything. It doesn't change anything. The model is just about representing our data. It doesn't know anything about the controller or anything about the view. So when the user makes a request, the controller contacts the model and it says, hey, I need some data. And then the model handles like talking to the database and different things like that. You could even change the model up so that it persisted to the file system instead, or something like that. It shouldn't matter to the rest of the program how we're storing our data. It just says, I call this function, I get the data back. And so we're isolating the database from the rest of the program. So if I wanted to switch to Postgres, for example, or maybe some other SQL model, or you're even just a file system, the rest of the program doesn't need to know that, doesn't need to change. It just says, I get a promise back. And that promise has the data I'm looking for. Now, we return that to the controller. The controller takes that information, puts it into the view, might do some extra work to make sure that it works nicely. That view gets shown to the user. Whether that view is built on the server side or the client side is not too big of a deal for this diagram. So you could be using render functions or a templating engine or something else to construct this view. You could be building it on the front end, like we've done with a lot of our jQuery examples, where we just have an API slash, let's say API slash animals. We get all of that information, and then in jQuery, we just dynamically build all the HTML. That's possible as well. So if I look at this diagram right here, this is a PDF that we've also got there. What I want you to do for the first 5 minutes is thinking about the MVC JPEG and how this part works. I want you to talk about going through that route. These different sections, you can replace the word ORM with models here. Which one of these belong to the model? Which one of these belong to the views? Which one of these belong to the controller? So just take a little bit of time in your groups with this diagram. Where do these different pieces work out? We're going to take about 5 minutes to do that in your breakout rooms.
The PDF isn't pulling up for me for some reason. I don't know if anybody
So
else
you have to have a plugin to open it in Visual Studio Code. You can also just like review it and find, or reveal it in Finder and open it up in whatever thing you want. Otherwise, it'll just look like like something else, like a big thing. So you don't have to open it up in Visual Studio Code.
Okay, thank you.
Cool. All right, so we're going to have you open it up. We're going to open up the breakout rooms at this point. Just take 5 minutes, try and identify what pieces of our program belong to which of these 3 pieces. Alrighty, folks. Still waiting for people to come back in, but we're going to start looking at things. Let's start out with the model. And we'll use this blue color to talk about things that are part of the model. Which one of these would that be included in? Which one of these pieces of our project have to do with the model? As a reminder, our model is responsible for representing the data of the application. It's not responsible for changing the data of the application. It's just responsible for holding on to it, making sure it stays, that we still have it, it persists, things like that. So which one of these include it? You don't have to say all of them, but what's at least one of these that is going to be part of the model?
ORM.
The ORM?
The connection?
The connection?
Database.
The database? Any others?
I mean, it seems like the API route kind of interconnect everything, but I'm not exactly sure.
Right. So I would say that this right here is our model. This is the code that deals with the data being there and persisting. So that's sort of our model going on there. Now, there is overlap. Not everything necessarily exists purely in one or another, but this definitely exists as part of it. Let's go ahead and choose a different color. So let's write somewhere else on here, the view. What parts of this are the view?
Basically that whole browser section.
So the whole browser section, we'll just put a big check mark here. Anything else? People are saying, no. I might include the HTML routes on there a little bit as well. So we have all of these included on that in our view. And we'll choose, yellow doesn't show up particularly great. We'll choose orange, I guess. So next lastly, we'll have controller. And what matches with controller?
The API routes.
The API routes would do that. But I would also argue that parts of the ORM definitely do that. The queries we looked at were just retrieving data, but you could also use it for more complex insertions as well. You could also say that that's part of the HTML routes where it's taking the model and putting it in there. So you could argue to an extent that all three of these are part of the controller based off of its task. So I'll go ahead and take a screenshot of this. And I'll go ahead and post this one in class activities here in just a second. So that might help you differentiate between all the different pieces. Now we want to see this in an actual example. We're going to be looking first at an example that doesn't really use models and doesn't use sequelize, so what an application might look like before. Then we're going to look at how we might handcraft something to solve that. And then we're going to look at, hey, let's try and actually use a library to help us out with this. So let me make sure that this screenshot is posted real quick. There we go. So we're going to clear all of this out. So what we want you to start out with is we're going to look at this application, which I'm about to show you. That'll be localhost 8080. So we've got, it's 2007, 2008, and we've got a brand new service, a brand new idea. What if people could like blog, but only 140 characters at a time? It's brand new, completely original, unlike anything you've ever seen before. So I'm going to enter my name, and it's so cool to have original ideas. We click submit, and it says, hey, so cool to have original ideas. It includes things like the time and who authored it. So I could put in another one. Let's put words in a celebrity's mouth. So let's pick a celebrity.
Kim
Tom
Kardashian.
Cruise.
I'm just going to go with Kim K. We all know who. What does Kim K say?
I'm mad at Kanye.
I'm mad at Kanye. Makes sense. And then it gets added to the list. It's persisted in a database. We can refresh the page. It's all there. Now everyone has to go to the same screen and anyone can be anyone. Obviously Kim K didn't say that on Chirpy today. But that's a good thing to look at. So let's take a look at what we do have. So in this unsolved folder, you're going to see that we've got a package.json. It's got express in MySQL, but the schema is blank. We named the database for you, and we named the table for you, but based off of the instructions, you're going to need to provide what columns are in it. Once you've provided that, if you look inside of this, we've also structured it a little bit different. Inside of server.js, you'll see that we now have require app routes, API routes app. We've started to separate the routes into like this separate controller file. We've started to isolate that from the rest of the server. So the server in this case is more about just getting everything set up than where everything happens. Everything is starting to get split into these different pieces, the model, the view, and the controller. Our API routes, we don't have any, but you're going to need to get all of the chirps and add a chirp. Again, the README, we'll talk more about this a little bit. You might not know which ones you need. So fortunately for you, the front end is completely done. And there's no server-side rendering to this. It's just the views going on. So we've also got all the client-side JavaScript. If you look inside of chirp.js, you can actually see what routes the front end is expecting to use. So you've got get/API/all. You've got post API/new. This is very common to working on a project. You're like, hey, the documentation, I'd love to see it. And they go, oh yeah, the documentation. And then you go, oh, okay, this is great. This is one of the reasons why it's good to have documentation. So but the code, you can see the routes you're going to need by looking in the front end JavaScript. The front end, again, is completely done. You shouldn't need to make any changes to it. What you're doing is you're taking on the role of a back-end developer, a little bit of a Johnny-come-lately to this project. We've got our front end. It's working great. But we don't have our routes. Our front end knows what the routes should do and take and look like, but our back end doesn't have that set up yet. We're going to take about 20 minutes to go over this, or for you to work on this, and then after that, we'll go over it together convert it over to a model, and then we'll see how we would use the Sequelize library to change that even further. Cool. So we're going to go ahead and open up the breakout rooms. Let us know if you have questions along the way. Good luck. All right, folks. So it looks like most everyone's back at this point. We're going to go ahead and get started. What we're going to begin with doing is making our database. And our database is just going to be part of our model or our persistence layer. So if we look at schema.sql, I'm going to add in a piece right here. Drop database if exists chirpy. You might also notice that when we said create table chirps, we included these backticks in front of it. This is a common way to just make sure that this is literally taken as a name. And it can also help to prevent SQL injection. And in fact, like the MySQL package, when it makes requests like this, includes the backticks on it. Is it necessary? No. But is it something you should expect or understand when you see it? Yes. And if the place where if you get work on a project and they're already doing stuff this way, go ahead and continue working on it this particular way. So let's start out with what are the columns that we need?
ID.
We need ID, and in fact, I'll go ahead and even put these in the backticks just so that you can know what this looks like. It's going to be an integer. What else about it?
Auto increment, not null, primary key.
Cool. What other columns do we need? Author, which is what?
Bar chart.
Yeah, I'm giving it away. I'm leading too much. And then we'll need one for body or whatever, chirp, whatever you want to call it. The reason I'm doing this is because if we look at the front end is using these pieces of terminology already. So we're just trying to keep it that way. If you wanted to name it chirp, that's fine. You would just have to go modify your front end. Or put in adaptation in your controller. If we keep the names all the same, it just runs a little bit smoother. And then lastly, we have created at. What type should created at be?
A timestamp.
Time.
Yeah. Date time. You could also have used timestamp for other ones as well, but we're going to use date time. And date time is probably more common for this kind of thing. You could also just have kept it as a string if you wanted to, but we're going to assume that it's a date time moving forward on this. So let's go ahead and run this in the workbench. It succeeds. Fantastic. Next, let's make sure that we're connected. We've got this config section set up right here. For this, I'm going to need to say, connect me to the Chirpy database. My host is localhost. My user is root. And my password is dbpassword. Now, we're not worried about a model folder quite yet. We'll look at how we could translate it into that. So we're going to go with API routes. And looking at our front end, we have a get all chirps and add a chirp. Let's actually pull up this one for reference. This is our front end JavaScript, and this will be the routes that it will call correspondingly. So we have one that's /API/all. So we'll say app.get/API/all function recres, and let's just send back an empty array for now. We'll work on the rest of it. Next, for adding a chirp, that's the /API new. So we'll say app.post/API/new. Let's double check our middleware, make sure that that's set up so that we can process those post requests. It is fantastic. And let's see what it's expecting back. Okay, it doesn't use anything back, so we can just send back like a status 200 error, like, hey, you did it. Res.status 200 for now. We might end up sending more back, but we're just going to send back a 200 that says, yep, sure worked. Or we could send back a 500 and be like, nope, it did not work, because currently it doesn't do that. Cool. So just by looking at the front end, we can kind of tell what we're going to work with. Now, looking at this, we want to get a list of all of our different chirps. You can see that we've already got our connection imported in here. So we're going to say connection.query. What'll be the SQL command we need here? I think you're muted, Hamaja.
Select
Select.
everything. I mean the
Uh-huh.
star from the database. I
So
mean, yeah.
from our table, and then we've got a function, the error and the data, and we'll just look at how we're expecting it to be used. The data is expecting back an array that has an author, body, and created at. So we'll just res.json the data right here. Now, if there's an error, we want to handle that as well. So we'll say res.status 500 .send or .end. Otherwise, return this. And we're just using return to end that, and then we'll pull this one out. So let's start this up. We're missing something on API routes line 29. Yeah. Cannot find module MySQL. That means I forgot to run npm install. So while that's happening, let's go ahead and work on the API new route as well. So we know we're going to get the body of a request. In fact, we can even see in post, let's see what data gets sent to us. You can see that the author, body, and created at is already given for us. It's even given in a specific format, so we don't have to worry about setting up created at. We're just getting that from our front end. So if we want, good thing to do right at the beginning is to just console.log rec.body. And the address is already in use, probably from our last application. Get rid of that. Cool. So we want to see what our request body is. So let's come here, refresh the page. Let's say, hello, or it's me. Hello. Click submit. And you can see that even though we haven't got all of this working, our client side actually, when we submit it, just takes the information and puts it on there. So it looks like it works already. In fact, this can be nice, but if we refresh the page, it's not there. So we're not actually using that. So you want to be aware of that when you're writing these kind of applications. Sometimes the front end will be like, you know what, let's just put it on there, and then it eventually will be consistent with the database. So just because you see it on the page doesn't mean it made it to the database. You want to refresh the page to make sure. Now, as we can see, we got author, body, and created app. And so we're going to go ahead and put these into our database at this point. Again, if we were being careful, we would sanitize our inputs, escape whatever the user is giving us so that they're not putting anything in there. But this is what we're doing for right now. Now, because of the way that we get the information from here, it can still be vulnerable to that stuff. So I could put like in a script tag that does an alert in my body, and then that would pop up onto the page. But we're just going to not put too much in at once, but just be thinking about that as you are making these. Now, what is my query going to look like? So let's make let's call it DB query. Let's close this again. So let's just hard code it for right now. Let's say that we want to add in a particular tweet, like me, hello, created at. That would start out with what SQL command?
Insert into,
Insert into,
and then chirps,
chirps, the name of the table.
values. Actually, before chirps, oh yeah. Do you have to put in parentheses like
Yeah,
author?
Yes, you have to go author, body, and then created at. Yeah. Let's go ahead, and I am going to make this a template string just so it's a little bit easier for us to read.
Me. Hello. I don't know the time one.
You could just copy that one right there. And that's a valid date format. Knows how to process that. Now, with these, we're going to actually put question marks for each one of them. You could also do this with set and an object, but we're just going to be a little bit more explicit here. So we're going to say connection dot query, this DB query, and then we're going to fill in the question marks. So the first one is going to be rec.body.author, rec.body.body, rec.body.created at. Then we'll have a function, again following the similar pattern as we did for our last one. In fact, I'm just going to pretty much copy that.
Is rec.body an object?
Hmm?
Would it make sense to destructure it?
Yeah, we could destructure it. So we could say const author body
Created that?
and then created underscore at. Need to make sure that it matches up over here. And then you could just get rid of the rect.body in front of each one of those. So you could do that. This one's a little, because you would only use it once. Sometimes you might just be like, this is fine. But also doing it this way is probably better. Cool. In this case, we're not sending back any JSON data. We're just going to send back, yep, sure worked. So we'll say res dot. Let's be explicit about it. Hey, 200 dot end. Everything went fine. Usually, if you just say res dot end, it'll send back a 200. If you want to be explicit about it, you can put that here. Cool. So now our application should work. Let's check. So we enter our name. It's a me, Mario. Cool. If I refresh the page, it persists. So I'm feeling pretty good about it. Now, before we move too far on, our front end, like I said, isn't going to change, but something that we wanted to do was to make a model for this. We wanted to look at what that might be. And this is kind of extra before we move on to the way that Sequelize would do it. So what I'm going to do is make a new folder called models. And in that, I'm just going to directly make a model called chirp.js. Now, models tend to be named singularly, and tables tend to be named as plurals. What does that mean? It means that the chirp's table is represented by the chirp model. So the chirp, this is a convention. There's nothing enforcing this, but this is a convention by default. So if I have a chirp model, it's going to have the chirps table. So it's the table of chirps versus this is like what the chirp model looks like that represents all of the different chirps. Let's go ahead and try and put some of this together. In our case, we're just going to make it an object, but when we get to Sequelize, we'll actually see that we make it a class, which makes it a little bit more flexible. But we're just going to make it as a simple object to start out with. So the first thing that we need is the connection. So const connection equals require. And if we notice it's over here in the config file, so I can say /config/connection. And so the next thing that I would do is look at my API routes and I can see, oh, they're making these kind of queries. They want to know, hey, select star from chirps, insert into chirps. Let's just start by copying this piece into here. So we'll say const chirp equals, and let's just say it's an object. Actually, yeah, no, we'll do it that way. And we'll say select. Won't take any arguments. Return, new promise, resolve, reject. And instead of sending back a 500 error, we're going to reject that error. And instead of sending this back, we're going to resolve it. And so now in our API routes, if we ever need to do this, we don't need to copy this whole thing here. Instead of a connection, I'm going to import chirps itself. So const chirp equals require dot slash models slash chirp. And I will say chirp dot select dot then So dot catch error res dot status 500 dot end, or dot send error, something like that. So now my controller doesn't need to worry about the details of how to get all of that. It just says chirp, and it might even say select. We might have renamed it all or something like that. It just gets everything for us, and we can evolve that over time. We could also look at the other one. Maybe we want to call this chirp.create. In fact, let's go ahead and make it a little bit more generic. Let's name this one read. Or find all. Find all seems like a good name. Next, let's work on chirp.create. So we're going to change this up a little bit, and we're going to take in an object, and I'm going to actually change up the syntax on here. So we're going to say insert into chirps set question mark, and then we're just going to pass in our data right here. If you wanted to break it out into different pieces, you could, but well, let's actually keep it as the original. No need to modify code. That works too much. So we'll take the data, and instead of destructuring rec.body, we'll destructure the data. And we'll return a new promise. And instead of sending this back, we're going to reject whatever the error was, and we're going to resolve anything else that we got back. And now our front end, or sorry, not our front end, and now our back end isn't going to say all of this. It's going to just say chirp.create rec.body. Then, as long as that succeeds, we'll send back our original response, which in this case, it would just be a 200. So we can say res.end, or we can catch the error and say res.status 500.send whatever the error happened to be. So this cleans up our code quite a bit. What do we do when we get API/all? Oh, we're just going to call our chirp model and say get all the data and then send it back as JSON. If you wanted to do server-side routes, you could just plop it into a view here as well. It greatly simplifies this piece of the code because now our chirp model is saying, oh, I want to get data from a chirp model. I just have a promise for that. So if I switch databases, if I want it to use a file system, it doesn't matter to the rest of the program. If I ever want to swap it out, it's super easy to do that because as long as it follows this interface and it returns the same object fields, I don't care. So it's an object relation mapper. So now someone on my team can have just created some models for us, and then the rest of the team doesn't need to know all the SQL that's involved in making that happen. Cool. So that gives us an idea about it. And so you're seeing some of the benefits of hand rolling our own, but we saw in the last example that doing it this way still involves a lot of duplication. You have to keep it in sync with your schema and other things like this. It can cause a couple of different problems. So what we want you to do next is we want you to take some time and look at something called Sequelize. Now, to guide you through what that is, we've got some questions. So answer, what is Sequelize? What advantages does it offer? What the heck is a Sequelize model? Given the below data, the table beneath it, how would you model this? How would you ask for records from it, etc.? So to learn all about that, of course, we want to consult the docs. So we're going to go to docs.sequelizejs.com, which I guess redirects us here. We're going to be working with I believe our examples. Let me double check the version that we're working with. I know that they just came out with one. We will be working with version 4 for this next one. So version 4, you could look, only reason we do that is because the versions were written for, or the activities we are using are written for version 4. Nothing wrong with version 5 or version 6. We just want to maintain compatibility with the exercises that we have. Cool. So this is the site for that. I'm going to go ahead and link this in chat, in class activities. We want you in your groups to go through and answer these questions. If you have any questions for us along the way, let us know. We'd be more than happy to help. Good luck. Alrighty, folks. We're going to get started here in just a second after everyone finishes piling in. We're going to review the questions real quick, and then we're going to see an example of an application that in fact, the Chirpy application that we just had earlier. Stop this real quick and make sure that we've got everything set up for that. Cool. So our first question, looking at this, is what is Sequelize? Well, Sequelize is a ORM. What's an ORM? Well, an ORM stands for an object relation mapper. So it's taking our relational databases and make them work a lot more like objects, where we can just ask them to do things, so that we're not writing SQL queries, we're writing this. So you might think of this as a JavaScript objects and functions being mapped to SQL, so that we can just SQL queries or SQL tables and queries. Is kind of how you can think about that. It's translating between the two of those. Now, some advantages that it offers. Well, it's easy to test. It gives you support for syncing between databases. What does that mean? Well, In Sequelize, you actually define the model, not in a schema file, but as part of your JavaScript, and then it does that part for you. Some other great things that it can do for you is it'll provide a place for your validations and specific forms of data. So, for example, you can say, hey, I want this to not just be a string, I want it to be an email address. I don't want this to be a string, just be a string, I want it to be a phone number. I want this to be, don't want this to be just a number, I want it to be a number between 1 and 12 because it's going to represent a month or something like that. So you can do validations to check that. And you can also enable complex SQL queries in pretty simple syntax. So to get it, you use npm install Sequelize. Now Sequelize works with a variety of different dialects. So it works with MySQL, it will work with Postgres, it'll work with SQLite, and others as well. So in order that you don't have to have all of those packages together, it asks, hey, please download a package that I can work with. And in our case, the package that we're going to be working with is actually not MySQL, but MySQL 2. They're different packages. One's not a sequel to another. This is like when you name a variable one thing and then you need it again, so you say MySQL 2, or your username is taken by MySQL, and so you write MySQL 2. So it's just another package, and it's the one that Sequelize uses. So we're going to be working with MySQL 2 as part of our dependencies. Now, a Sequelize model is a representation of table data for Sequelize, just like we kind of saw in our previous example. What it's meant to do is that if I have a model called chirp, it's meant to represent the chirps table, like we saw earlier. If we scroll down here, we can see that we have this table. If we were to model this in SQL, we would do this. So var table name equals Sequelize.define. Right, this, let's go back to the preview on that one. So this table name right here, this will be what you refer it as, and this will determine what it will be labeled. So if I labeled this, for example, to be countries, country, by default, this would create a table called countries. So this is the name of the model. And this will often be how it's referred to elsewhere. So it pluralizes it by default. Next, we have country. We can include other aspects to it, but something you need to include on each type is Sequelize.string. What do you think this maps to in, I'm double clicking too much on all of this stuff. What do you think this maps to in regular SQL?
Varchar.
Varchar. Anyone want to guess what number is associated with it?
30?
255.
I'm pretty sure it's 255. I'd have to double check myself, but it's a decently sized number. You can work with more specific types if you want. Integer corresponds to int, and a lot of the types cross over. Varchar and string is just one of the more notable ones.
So
Yes,
do you keep
255.
Go ahead.
you keep the table name as table name? Is that what you were saying? And then it just
Well, we would actually go in here and write
countries.
country instead.
Gotcha.
There. Now, there's some additional options you might see in this section right here. So by default, things will pluralize, but this says freeze table name true. So what that would do is that it wouldn't say countries anymore. It would, or the table name wouldn't be countries. The table name would just be country. They would match exactly. So if you want to enforce that, you can. But by default, it's going to try and pluralize it. And we usually let it. But that's something to be aware of. So let's erase some of the specific pieces we were looking at right there. All right. Next, we've got table name. Usually you would also have the table name be country at this point, rather than you usually wouldn't write it out as table name. Table name.sync, force true. When you sync the database, what you're going to do is what it does is it goes in and it says, hey database, do you already have a table called countries? And if force is not set to true, if it already has a table called countries, it says, oh, we'll use that one then. If your database is as force set to true, then it will drop the old table and create a new one each time. Now that's useful if you're making schema changes where the number of columns isn't the same. But if your columns are staying the same, having this on will drop your data each time you start up the database. So you can set that to be false if you're not making any changes like that. And you can set it to be true if you want your schema to be constantly updated. So after we create this table, after this is our chirp.create, as it were, country.create. This is making a new row in the database. And it gives a property for each one. Hey, the country is equal to Afghanistan, the phone code is 93, the capital is Kabul, and the independence year is 1919. So now, after having defined it, and after having created it, we didn't need to write any of these methods. They were just available for us to use. And you'll also notice that this is a promise-based framework. We don't have to deal with callbacks. We can just use promises, which means you can also use await async if you want pretty easily with this framework. So it's really helpful. So let's look at the app, this time with the sequelize model. So inside of here, we've moved a lot of the different pieces into a folder called app, but you're going to see very similar pieces. So our public folder is kind of acting as our view folder because we're not doing server-side rendering with this. We're asking the client to do all the rendering for us, so there's no views folder. All of it exists in the public folder, and then it's created dynamically on the server. But then we've got config with our connection. Our connection looks similar. We're still exporting a connection, but this time it's configured to work specifically with sequelize. This is the name of our database. This is this. Let's go ahead and change this to be DB password. And the other thing you'll notice is inside of the schema.sql, there's no table definitions. There's no table definitions. We still have it because we need to make sure that that database exists, because there needs to be something for us to attach this to. But that's it. Use sequelize _ chirpy. And if we look here in the sequelize chirpy, wherever we put it, there it is. No tables right now. In our model, we've got sequelize, the library. We've got a lowercase sequelize, which is our specific connection to our database. So the uppercase sequelize refers to the library, the lowercase sequelize refers to our connection to the database. And we say, hey database, we'd like to define a table. We're going to call it chirp. That's the name of our model. So what's the table going to be named? Chirps. So once all of that's done, we say chirp.sync. We're not setting it to be forced to be true, but this is what is going to create that table that we defined here in the database, and then we're going to export it. Then we're going to export it. So now, inside of my routes file, I can say chirp.findAll, and then I could even pass in a list of criteria or conditions that I want it to work with. I don't have any this time, so I'm not doing that. When I need to make a new one, I say chirp.create, and then use the results from it in this promise-based framework. But I didn't have to write any of that. I didn't have to customize any of that. Just because of the way I've defined it, the chirp model knows how to do all of this because of the Sequelize library. So I just define it in one place. I can use it somewhere else, which is pretty cool. So let's go ahead and start the web server. So I'm going to say node server.js. Uh-oh, let's see. Did I not set my password properly? I bet I didn't save my password. Yeah, I didn't save it. Let's start that up again. There we go. Now, before I even do anything else, let's look at Sequelize Chirpy. If I refresh the schemas here, and I take a look at Sequelize Chirpy, I now have a table called chirps. And its properties are as follows. If we look at the different columns, it's got ID, which we didn't have to specify. If we look at the models, nowhere in here are we specifying an ID. It just comes along for free because Sequelize says, of course you would want an ID column. Now you can tell it not to have one using those same options we saw, like freeze column table. There's an option to be able to, or freeze table name. You can do that, but we want to include it. Author, varchar 255. Body, varchar 255. That's what string translates into. The date gets translated into date times. And you'll notice we actually have these two extra fields. So we had created at, which we had before. But as it turns out, by default, Sequelize is going to make these timestamps for you. And it's going to maintain these timestamps for you so that whenever you create a new entry, like we'll do here in just a second, it'll automatically use the created at time. It'll say like, what time is it right now? Plug it in there. And if we ever update it, it'll also maintain the updated at time. Now that's maintained by Sequelize. If we come in through the workbench and change those, it's not going to, it'll stick like that. It's not going to necessarily change those. So that's something being maintained by our JavaScript. It's not setting up SQL to do that. It's just doing the work itself for that to happen. Now let's actually use this. I believe it's on localhost 8080. And our front end doesn't know the difference. In fact, most of the rest of our application doesn't care. It's written almost the exact same way. So I can say my name is Eric and I replaced the backend and nobody noticed. Submit. Let's refresh the page, make sure it works. Seems to. And let's just take a brief, quick look at the rest of this. So inside of our API routes, after we've created all of this information off of the body and our front end, if we look at it, is the exact same. Let's take a look at our database just to see what that looks like. So we'll select everything that's in there. We've got the ID, the author, the body, the created at, and then these two fields auto-populated. We didn't provide a value for those, we just made them because when they were created, those two fields got filled in. So all told, the controller doesn't see very much difference from what we did last time because we kept the same interface, and the view doesn't care. So if we change the database, let's say we moved to another dialect of SQL that Sequelize supports, we don't need to change that even. We just say, hey, yeah, here's a model, and you interact with that. You don't need to know about the database at all. API routes, not interacting with the database. Chirp here, not interacting with the database. We just have an object that seems to be able to get that information for us, which is pretty cool. Questions?
So did you create the database in your MySQL workbench before, or is that done by Sequelize?
You do need to make the database beforehand, but that's it. You just need to make sure the database exists because it needs to know what database to connect to work with it. So that's the only thing. You don't need to make the tables ahead of time, but you do need to make the database ahead of time. Otherwise, it says, okay, who am I supposed to work with, etc.
Okay.
All right. And with that, we're going to go ahead and break for lunch. When we come back, we're going to practice some of this. We're going to look at the Star Wars app that does it. We're going to look at a Sequelize library. We're going to look at how we can convert some of a homegrown ORM to using stuff with Sequelize. Things like that should be pretty fun. All right, cool. I'll see you at 12:45. Have a good one. Alrighty, folks. Welcome back from lunch. Hopefully y'all had a good time with it. What we're going to do at this point is show you a full working Sequelize app, but we're not going to show you the code for it. What we're going to have you do is try and work with the code yourself. You'll have the example of the Chirpy Sequelize app to work off of to kind of give you an idea of what you want to build. So I would reference that throughout this. So in the unsolved version of it, you're going to have a significant portion of the app done for you. You're not going to be building it from scratch, but let's take a look at the app before we dive too deep into that. So on localhost 8080, we've got our Star Wars app, very similar to the app we made before. Let's go ahead and add some new characters to the Force. So let's say I'm going to add Yoda. He's a Jedi Master / experimental grammarian. He is 900, I guess, and he's got a lot of Force points. So we added the character. We can look at our list of all of our characters, and there's Yoda. Very similar to apps we've built in the past in terms of the functionality that the user sees. Where this is going to be a little bit different is the technologies that we're using to organize it as our projects get bigger and bigger. So most of this is going to take place in the app folder. That's where we have most of it, but there's still some outside of it. So let's look at those. So we've got a schema.sql. This one actually creates the table with all characters. Now, what you're going to want to do as part of this is make sure that you've got all of this installed. And inside of our app, we have sort of this homebrewed ORM, that's similar to what we worked with before, except it's all callback based and it's kind of hard coded and it's hard to make new models for it. And inside of the schema.sql, you've got a table that you have to maintain yourself here. And your connection is based off of the MySQL connection and not a Sequelize connection. So what you have in reality is a app that completely works already, but what we want to do is swap out the technology. We want to swap out the technology so that we're no longer using this homebrewed ORM. We're going to be using Sequelize. So the README has some steps on how to do that. First of all, you're going to need to install some of the relevant packages. Next, you're going to need to delete the ORM and make some new configuration setups. So you're going to create a new folder called models. You're going to create a character model that exists in there. And then we want to remove all the references to this. Very common in long-standing projects. You might say, okay, we were working with this technology, but maybe the vendor isn't there anymore. We can't, it's not supported, or maybe our needs have changed, or maybe we're trying to scale and something needs to be different about it. Many times you're going to want to have to swap out one technology for another in some capacity. And in well-architected applications, that process isn't that difficult. So that's what we're trying to do with this, the Star Wars app. So you can run it, make sure that you run the schema.sql to just so that you have the database to work with if you want to remind yourself of how this application works. And then we're going to be spending time converting it over. So we'll be working on this for the next 30 minutes. After that, we're going to go ahead and review that process, and then we'll talk a little bit about some more stuff with Sequelize from then. Any questions before we get started? Cool. I highly recommend using the O3 Chirpy Sequelize as a model. If you ever need to reference how any of this works, the Chirpy Sequelize version of it does a great job with that. So we're going to open up the breakout rooms. Good luck. Alrighty, folks, looks like we're almost done piling back in. Almost. And what we're going to do is convert this original application from, oh, looks like my camera's, there we go, much better. So what we're going to do is convert this application from using a hand-rolled ORM to using a more, to using Sequelize, to using something that's maybe a little bit more understood broadly, a little better understood by perhaps people that would be new to the organization because it's popular and well known. These are all things that organizations are going to think about when they think about what things to adopt. How quickly is it to, how easy is it to get people that know this technology? How easy is it to change or pivot to something new if this stops suiting our needs? All of these are things that we want to dwell on somewhat. So let's look at what we're going to do. So the first thing I want to do is I'm going to just comment out this database table. Now, if we wanted to keep the data in our existing table, then we would write what's called a migration. A migration is a way to sort of gradually change a database over time to be one version or the next version or something like that. We're not going to go into too much depth on that. In this course, I'm going to reference it. We might do an office hours on migrations, but most of the time you're going to be working with brand new stuff throughout this course, so we don't want to spend a lot of time talking about migrations or moving data from slowly as you change the schema over time. We wanted you to just kind of get your feet wet with what are we starting with. But we'll keep the rest of this. And in fact, we don't need to have use Star Wars there anymore either, because we just need to make the database. We're not going to use it. You could leave it on there in case you wanted to run some select statements afterwards or something. But that's finished at that point. The next thing that we're going to do is I'm going to go into my routes folder and I'm going to erase any references to the ORM. So I'm going to say, all right, nope. And instead of this, I'm just going to say res.json and put in some filler data. So in this case, it's just going to be an object. If I look at my schema, I can grab the different properties it can have. I can just make this mock object. So ID 1, role test, age, and force points. Age 9, force points 9. I like to do this because it kind of keeps the application working. In terms of being able to display information. So we have these mock objects, even though we're going to replace that.
Do you also need a name there?
I believe you're correct. Let me double check. Yeah, route name and name. So we'll put those back on there. So we'll say route name test and name test. So that'll work. And then we're just going to say, hey, if they're asking for any character, we're going to give them back this. Otherwise, we're going to give them back an empty array. It's probably going to, might cause problems, but it's at least not going to break everything. And it kind of gives us an idea of what we're going to be building towards as well. So now that I've eliminated this, I don't need the ORM. I'm going to go ahead and we'll leave this here for reference. Our connection is going to change though, because we're no longer going to be using the MySQL package. We're going to be using the MySQL 2 package. So I'm going to stop this briefly. I'm going to say npm install sequelize and MySQL 2. I'm going to comment out all of this and start from the beginning. So const sequelize the library equals require sequelize const lowercase sequelize our connection. And in this case, we'll need to reference the name of the database, which will be whatever the schema said it was, which will be Star Wars. And then we'll also include our username and password. Later, we're going to talk about how we can hide these pieces of information, as well as when we deploy things, what extra steps do we need to go through in order for that to work. We're going to include a whole bunch of different host options. I'm just going to copy these over because it's not particularly interesting to see me type it. We've got the host, the port. Remember, Sequelize can work with multiple types of databases, so we have to tell it that it's MySQL. And this has to do with how many different things can be connected to it at once. Minimum of 0 and a maximum of 5. And if a connection is idle for more than 10 seconds, just turn it off and then you can bring it back up if needed. Lastly, we'll say module.exports equals sequelize. And then we can get rid of this portion right here. So now the rest of our application can use this. You'll notice that we're exporting the connection here. Lowercase sequelize again is the sequelize connection, and the uppercase S is referring to the library itself. Cool. Next, we're going to get rid of the ORM, which I'm going to do just by commenting it out. And we'll go back and delete it once we don't need to reference it anymore. We're going to make a new folder called models. And inside of that, we're going to make a new model for our characters, which we'll call character.js. All right. So we'll need a reference to sequelize. And we'll need a reference to our specific database connection as well. So that'll be over in the config folder inside of our connection.js file. Next, we need to actually make our character. So character equals sequelize.define, and then you usually name it the same thing as the file or the singular version of the table. What's the table for this going to be named?
Characters.
Characters. Now, if we go back to our schema, we can actually see what pieces we need. Let's also make sure we save everything there. Where we have each one of these pieces. So first of all, do we need to define the ID?
No.
No.
No, because sequelize, unless we tell it not to, will do that for us. Cool, cool. All right. Next thing that we're going to do is we're going to go ahead and add the route name. So we'll keep the column title, route name. And if we look at the previous one, we would say that the type is what? Sequelize dot what?
String.
String. Cool. You could also have written this as route name and just said sequelize dot string. Either one of these works. When you have it in this format, it makes it easy to add a lot more conditions to the column because you can add other properties. But if you know that all you care about is the data type, you can just write it out like this. In fact, the solution that we'll post has it written out like this. But either way works. If this just allows you to add more things besides the type, because you can add other properties to it. And I like to do that ahead of time so that you aren't running, or when you go back and edit it, you don't have to do more typing. It's just saving yourself a little bit of effort in the future.
By default, is not null set to true?
I believe so. But I'd have to double check. I believe you can put that on here. So let's see.
I think it's just
Allow
not null.
null, false. You could add that on there if you want to set it explicitly. I forget what the defaults are, but you can add in a property called allow no true or now null false. I just forget what the default is. So we'll do that for the name and for the role as well. I believe it is not null by default, but I'd have to, I'm not confident enough in that answer without double checking it. Let's see. We'll put our age. What will be the type here?
Integer.
Integer. And then we'll do the same thing for force points. Cool. And so that concludes our character definition. What else do we still need to do with it?
Inside that object, they don't need the commas unless there's another.
Right. It's regular object rules where you just don't put a last comma. The comma is just used to separate one property from another.
No, I'm sorry. Like within, so the objects or the like in the top one, route name, string name has a comma at the, or sequelize.string has a comma at then. Is that just if you add another?
So are you talking about line 4 or?
No, line 8, sorry. Or 7.
Oh yeah, no, that's a typo.
Okay.
That was there because we had other options there and
That's
I removed those and I forgot to remove that one.
Awesome, thank you.
Cool. So the next thing that we need to do is, because this is connected to whatever this connection is, we're going to call character.sync. And then we're going to export it. So now the rest of our application can use it. Now, let's go to our API routes. So where we were asking for our ORM, we're going to ask for the model. So we'll say model character or const character equals require dot slash models slash character dot JS. And you could even remove the .js on there if you needed to. So beforehand, we were saying,
2 dots?
Pardon?
Do you need 2 dots there?
Yes. Thank you. All right. So we want to search for a character previously. And if we look at the ORM, we can see inside of the config, the ORM, if we look at that field where it was saying search character, it would say our query, let's see, which was select star from table with route name, and then we would just send back the result. So let's do that. This is only going to send back 1, we want to keep it the same as the front end. So we're going to send back an array of one item like we were doing before. Let's see. So this should technically be that. Let's double check with the front end, make sure that's the case. So this will be called on the all page. All.html loads in the front end JavaScript of all.js. And when we hit our API, that's getting all of them. I want to look at a specific one. Search character, the data that we get back. We assume that it's an individual. Cool. So we'll just need to make sure that we handle that way. So let's go back to our API routes. And let me double check the ORM that it's route name, callback, result. Interesting. I would have thought that it would have pulled out the 0th one. Well, we'll double check. We'll double check that that works in just a second here. So let's go back to my API routes. And we're going to say character dot find, and you could say 1, and then we can give it the criteria where we say, hey, we want this to follow or to match the route name. So we'll find 1, and we'll get rid of this for now. Then we're going to say where, and then give it our list of criteria. So where the route name, which is what we were using earlier, is equal to rec.params.characters. So whatever someone wrote up here. Once we have that, then we'll take that character and we'll send it to the front end. Now that's if a character is provided for us. If a character is not provided for us, then we're just going to send back all of them. So we can say character excuse me, we don't need to have any criteria here. So we'll just take the characters and we'll res.json the characters. Now, if we were being extra good here, we would also provide for catch errors and do 500s, but that's omitted in this case. Go ahead.
On line 28, should that be character, not result?
Yes. Cool. And if you wanted to do async await, you could use await for it if you wanted to in this case as well without too much trouble. Cool. Next, we're going to take this information from our new character, and instead of using orm.addCharacter, we're going to insert a new one. So that's going to be character.what. What method will we use here?
Create.
Create. And then we can pass in either all of the attributes individually, or we can mount them all in here. So for the route name, well, I'm going to do a similar transformation to what we did before. We need a way to figure out the route name. If we look in the ORM, it used to make the route name in there. So we'll have to pull that out temporarily here just because it doesn't do that for us. Later, we'll learn about how we can make our own custom functions so that it would do that for us. But for right now, we're just going to pull that part out.
Route name references the URL route name that it'll be.
Right. So the route name is when you say /API/Yoda.
Yeah.
That works fine, but we don't want Darth space Maul. We want it to just be all Darth Maul, all lowercase.
Copy.
All right, so we take the route name, and then we're also going to include some of the other pieces in here, like the name is going to be everything else. In fact, I'm just going to say, go ahead and take all the other properties of character and just put them in here. Now you could have pulled all of those out, but that's just what we're submitting right there. You could also, if you wanted to be careful about it, be more explicit and just say, hey, just these properties. That way, if the front end sends you extra information, you're like, not going to stick that in the database, like created at, updated at, or if it tries to modify other properties, you're saying, no, you don't get to choose that kind of stuff, etc. But we're just going to say this. Now, once that's done, we're going to basically send back a thing that goes, yep. And if you ever see a status code and you're not sure what it means, I think Wikipedia has a good list of all the status codes. So in our case, we had number 204, which is no content. We processed your request, but we don't have anything to send back. Now, there's a pretty great one on here, which is status code 418, which is I'm a teapot. The world out there is full of really interesting things. So this one was in a April Fool's joke, and then a bunch of people actually specified it. So it's a real status code. Now you can actually use it. You never should, but there are some fun Easter eggs like that in there. That's the only one I know of in the status codes, but it's there. Mostly, you probably won't be using status code 418. You'll also notice that there's no status code 420 for obvious reasons. So there's a bunch of fun little things you can see in the history of things, even status codes. There's a bunch of interesting people making interesting decisions throughout the course of programming. Cool. So we are out of routes at this point. I'm going to go ahead and run the schema file again in my workbench just to make sure that we aren't colliding with any of the previous tables that we made. And then we're going to start it up and see what happens. So if I look at my Star Wars database right now, it should be completely empty with no tables in it. So if I open up Star Wars, I can see there are no tables within it. Let's move over to that. I think, make sure MySQL 2 and Express. Or sorry, MySQL 2 and SQLize are both there. I think I typed that into the wrong one. Then once that's done, we'll start the server up. No errors right off the gate. Feeling pretty good already. So let's go visit localhost 8080. Make sure our functionality still works. First of all, let's check in the database if our table exists. So we're going to refresh the schema. And we can see that in our tables, we now have the characters table with currently nothing in it. Let's go ahead and add something to it. Make sure all of our data got in there correctly. So let's click add new character. Who do we want to add to the Star Wars universe?
Boba Fett.
Boba Fett, role, bounty hunter. age, I don't know,
43.
43. Force points, lots, right? So now we've added that character to the force. First of all, let's make sure it made it to the database. So we'll run this select query again. And we can see that Boba Fett is now there in the database. We can see the created at and updated at fields are there. So our application was able to work with all of that. Fantastic. Next of all, we should be able to see him in the list of all characters. Excellent. Now let's search for Boba Fett. And we're able to find him. Cool. So all of our functionality works there. We're feeling pretty good about it. We might add a few more characters in there just to test it out, but there you have it. Questions?
In your API routes, and I think in some of the other files too, you go between doing like character in uppercase and then in lowercase. Is there a reason for that?
Yes. So character, uppercase, is the model. When we use character and like API routes right here, this is just the data for the character, for example. Like this is the data of the character. So this would be equivalent to the table, and this would be equivalent to like a row, you might say. And so I'm naming those the same. Could I name them something else to help differentiate that? Like name this like DB character or something like that to help differentiate it from the model? Yeah, but you'll also see this be used in a number of places. So it's good to know the convention. Usually uppercase character is like a blueprint or a class or a model or something that represents a group of something or a type of something. And then one that's lowercase will be an actual instance of it or a row in the database or a particular object that has all the data in it. Things like that.
Can you scroll to the bottom of that file real quick?
I'm going to change that to be const too. We'll pull out all the stuff we're not using anymore.
Okay.
Right on. Any other questions?
Is that uppercase like character, is that kind of like a constructor just for a table?
Kind of like that, yeah. In fact, we'll see that we can actually use it like a constructor in the future. It's got properties like this where we can say character, but we can also make new characters and do things with them. And we'll see how we can do that. But yeah, and you could think of them as being similar to constructors.
Thanks.
On line 56, is that the rest operator?
It's the spread operator. Rest grabs things together into an object. Spread takes things in an object and pushes them apart. But yeah, it's the 3-dot operator. So what this is doing is saying, yeah, any of the other fields you might have in here, just put them directly in there. So, hey, you have age, force points, all of these other properties, just section them out so that they can be copied into here without having to actually write the part where we copy it all out. Otherwise it would look something like, we'd fill it in like this. And that's so much typing. Now, this is better because it won't accidentally add other things other than what I wanted. Or this might be better because then this handles if I make any changes or I add new fields, I actually don't need to change my controller. Because it's just, hey, whatever this gives me, and then I'm going to count on the character model to say like, hey, yeah, you can add that, or no, you can't add that, things like that. Alrighty. So let's look at one more example today. We've got one more big example that I want us to work with. And so this is going to, and tomorrow we're going to introduce a tool called Sequelize CLI. It'll show us a way that we can sort of start programs more quickly. It'll help us make things, and it'll also do some fancy JavaScript for us as well. And it'll allow us to use environment variables or set up different criteria for things. It'll be pretty neat, but that's tomorrow. I want to practice some of what we learned with the Sequelize library right here. So I'm going to start that one up as an example. Oh, I bet I forgot to update my password in the config file. Yes, I did. Happens every cohort, that's how I know. All right. So here we have an app that feels in a sense very similar to our Star Wars app, but it's going to have a little bit of extra criteria around selecting things. So let's add a couple of books. So give me some suggestions for books.
To Kill a Mockingbird.
To Kill a Mockingbird by, oh gosh, Harper Lee?
Yeah,
Is that
Harper.
correct?
Yeah.
Yeah, genre, YA, I don't know.
Classic.
Nonfiction or
Literature,
classic.
I don't know. She wrote like one book for a long time, and that was it. And then I think she made another one, and then that one didn't get nearly as famous. Pages, let's just say it's 200 pages. I don't remember how many pages it is. I guess it depends on the edition you have and how big the pages are. So now that's in our books, and we can see that's under this list of books. And we wouldn't really call it a short book, so it falls into the long book category. I'm going to make a new book.
Yeah.
Interesting things I have done. Author, Eric. Genre, biography. And it's like a page. It's basically my resume. I'm going to upload it as a book, right? So we look at the short books. And that's a pretty short book. So that goes into the short books category. And I can even search for some of these other books. So I could say, let's look for To Kill a Mockingbird. We search for it, and if we scroll down to the bottom, we can see it. There's even a button to delete it. We're not going to do that though. Under author search, let's search by me. We search by that. We can delete the book. We could even search by genre, where we would take biography, and again, we would see the results there. Or if we said science fiction, we wouldn't see anything there because that doesn't match. Now, if I want to get rid of the book, I can also click delete book. We're like, that's a resume, that's not a book. And we go back to my list of books, and now they're all there. So it's like the Star Wars, except we're able to search for a number of, by a number of different criteria when we're looking for it. And we're able to also delete books. So that's what you're going to be making. It's largely about being able to select a bunch of different books. So the adding all of them, the finding all of them, very similar to the exercise we just went through. The deleting, going to require a little bit more looking into the documentation. How to query all of the different info that you want, going to require more look into the documentation. If you look under querying right here, you can see how to do a lot of that. So, hey, I want to do things. It has a lot of code examples in there, how to use where clauses, how to use operators so that you can handle things like greater than or less than for the page count, etc. Cool. So we're going to open up the breakout rooms at this point. Let us know if you have questions. We'd love to help you out. You're going to want to make sure that inside of your connection, you include your database password and that you copy over the schema file and run that so that you have the database that works before you begin in earnest on the rest of it. All right, good luck. All right, folks, looks like everyone's starting to finish piling in. Still got a few people lingering. First thing you want to do is inside of your config file right here, you want to make sure that DB, your database stuff is all set up. So you're connected to the correct schema file or the correct database that you set up in your schema file. You've got your database password set up. All of that's good to go. Let's see, unsolved. And let's just start our server while we work on this. Cool. So if we look in here, we've got some directions on what our model should look like. First of all, we're going to need to require the sequelize library. So we'll say const sequelize uppercase equals require sequelize the library. Next, we need to say our connection equals require, well, our connection file.
And if we wanted to create another table, we just create another file for that table. So it just models each one. Okay.
And we'll even see how, we'll be doing this tomorrow. We'll even see how we can have a index file that helps link everything together as well. It gets a little bit complicated because it does more than just say require app for it, but it can be pretty useful, and we'll see that more tomorrow. Now, for making a book model, what you name it here, const book equals doesn't matter so much most of the time. It's just a variable name. But what comes next is the bigger deal. So in this case, what would it be?
Lowercase sequelize.
Lowercase sequelize.
Dot define.
Dot define.
Dot define. And then this one.
Book.
Book.
KSP book.
Which will be the singular version of it, which will create the books table in the database. From there, we include all of the fields that are listed here. I'll just sort of copy these into here, and we won't make a full object for them. We'll just do the shortened types. The title is sequelize the library, because that has the definitions for all of our different data types, dot string, and that's the case for most of these, with the exception of the page count. Then our pages is going to be an integer. Cool. What else do I have to do in this file?
Sync it.
All right. Book.sync. What
and
else?
then export it.
Export.
module.exports equals book. Cool. So now the rest of my application is able to use this. Now my HTML routes, not really going to use any of these. These basically amount to send a file. We're just using these to kind of worry about the URL names. But in my API routes, that's where I'm going to start using all of this. So I'm going to change that over to be const. But we're loading in our book. So if I want to get all the books, what's that going to look like?
Book.find all. Dot then. Result arrow function return res.json result.
Yeah. And then if we were being extra careful, we could also put a catch statement on there. So catch error res.status 500.send error, something like that. Now it's going to be very similar to that for most of the rest of these, with the exception of the post requests. But all of our GET requests are going to look a lot like this. In fact, let's go ahead and copy this over, where this one is going to be looking for a things by title. How is this going to change?
Book.find one.
Find one.
Yeah, so we could use book.find one. It depends on the format that the front end expects. Is it expecting an array of options, which might only have one, or is it expecting one? Let's go look. So in this case, API/book, that's going to be when we want to find a specific one. So if we click on view, or if we look at how it's being searched for by title, let's look at that. So that would be inside of our JavaScript, view.js. We look at this, it says render books. Let's look for the render books function, which is defined right here. And it looks like it's expecting an array. So in that case, we use find all. Now, you could say, yeah, find one, but it's also possible that multiple books would have the same title, which is why we're working with it this particular way. So find one is often appropriate, especially if you're doing something that is guaranteed to be unique, like an ID. You'll often use find one in that case. But with book titles, that's unfortunately not the case. There's a lot of book titles that unfortunately have a lot of overlap. So we're just returning back the array of everything. But a great way to check is just to look at your front end code if it already exists, if you're working on a project that's already established, and you can kind of think about that scenario. So we're going to leave it as find all for now, but if you changed it to find one, you would just need to make sure that your front end also accounted for the fact that there was just one. So what are my criteria though for this book?
Where the title equals rec.params book.
Yeah, where the title matches up with the book there. Anything else? Seems good to me. So let's now take this for genre. Very, very similar to what we had before. What's different though?
Where genre equals rec.params genre.
Yeah. So one of the nice things about these sequelized models is we're not having to hand write one for each of these. We just have this format where it works out pretty well. Let's try same thing for author. I'm just going to copy that over where we'll just replace author with author. And now we have books that are long and books that are short. What would y'all say is the threshold for a long book? It says 150, but I want to sort of take a straw poll here. When does a book become a long book?
Over
300
500.
pages.
I'd say close to 300.
Got a couple of different responses. I'm going to post this in Slack and we'll see what the responses we get are. So go ahead and add a reply to this. When is a book a long book? Go ahead and add a reply to that and we'll look at what the numbers roughly shake out to be and we'll use that as our average. While that's happening, any questions?
For your first one, I think you did Rec.Ram's book. Is it supposed to be Rec.Ram's title since we're searching for the title?
It's whatever's written up here.
Oh yeah, gotcha. Okay.
So if it's book, then we'll use book. If you wanted
I
to
see.
change it to be title, you could do that too. But oftentimes you'll have some sort of disagreement where someone wrote it one way, one place, and then someone wrote it somewhere else. And then you're like, okay, I'm just gonna make this work for right now by mashing them together. Now, would it be best if we probably said title right here? Yeah, probably, but it's you don't have to have it be the same. All right, let's take a look at this. All right, so we've got 300 pages, 1,000, 750, 500, 1,000, 400, 350, 700, 300, 600, 400, 400, 300 plus 400. I'm thinking about 500 or so pages seems like a good barometer, seems like a good average between all of those. For all the people who are like over 1,000, I'm like, oh, so we would like epic fantasy. It feels like the genre in that case. So let's go with 500. So what we want is if the book is 500 pages or more, then we want to do that. It'll still be in this same format, but our where clause can't be exactly this. Won't be exactly this because we're looking for a condition that's greater than or equal to, not just it matches it exactly. So when we add this here, we're going to need to talk about some categorization right there. We're going to need to start applying what we might call operators or opcodes to make that all work. So let's go over here and you might see operators, range operators. And this can help you say, oh, these are the values that I want. Maybe it contains something. And we can see that there's a big list of aliases that we want to work with. So one of these is GTE. If you look further in the documentation, you can see that that stands for greater than or equal to, as opposed to just GT, which would be strictly greater than. So we're going to use this as our opcode. Use that to make sure that that matches up with what we want. So we're going to say, hey, if it's greater than, if pages, rather than providing a direct value, we're going to make it an object and we're going to apply some operators to it. So we're going to say $GTE, if it's greater than or equal to 500 pages, was the consensus that I sort of pulled out of there. If it's more than 500 pages, definitely a long book. And we will say, consequently, that everything that is less than 500 pages is a short book, though I might disagree with that too. Where you could say like medium books, you could start differentiate them into different categories, etc. And then we've got two more to deal with here. Let's go ahead and finish those up really quick so we can get into office hours. So we won't be running books.find. Oh, and I need to make sure I grab the last two of these here. So it won't be books.findAll. What's the method we're going to use when we're making something new?
Create.
Create. And that will be based off of the body. of the request. So I'm going to just pass in rec.body right here, rather than pull out each one of the individual pieces. And I'm just going to assume that that's already there. If I was being less lazy, I might do something like this so that I know exactly what's being pulled out. Like so. Either one of those would work. I'm going to go with rec.body in the interest of time. And then, same thing. If there's results, we'll send it back. Otherwise, if there's an error, we'll send back that error. Now, the result here is mostly going to be, hey, here's the IDs and other things that you need in that particular case. Now, next comes one of my favorite named methods that we get with SQL models. I don't know why, it just is. So if I want to delete something, it's not book.create, it's book.what?
Destroy.
Destroy. There's just something satisfying to me about that. I don't know what that says about me. But we obviously don't want to destroy all of the books in the database. So what are my conditions?
Has to be like where ID.
Yeah, where? Again, the same clauses we're using up here. So where ID is rec.params.id. And then again, we can get the results of that and send it back to the front end. And we're good to go. Cool. So we get a lot of capability just from defining what a book looks like in a file. We don't have to run a schema file. We just have a database available to us. And then all of these features get built in, and we don't have to know all the SQL to just make our program run or find all the pieces for it. It's very easy to see in this way how the two can work together. Cool. Neat. Now, if we have questions around this, I'm going to go ahead and, since it's already 2:36, go ahead and say we're going to shift into office hours. We're going to take 2 to 3 minutes to just get that ready. And then first thing, order of business will be answering any questions about the activity we just went over. After that, we'll open it up more generally, anything about Sequelize or making models or MVC or any of the other stuff that we talked about as well. We're running up close to Project 2. Project 2 starts next week. We'll be talking about that more next week. The schedule changes up a little bit because of the 4th of July weekend kind of offset everything by a day or so. But we're going to see if we can give you an idea of what's coming up by Friday so that you can start planning what you might want to do for that. Cool. So we're going to take 2 to 3 minutes for office hours. The TAs will be looking at the wait list for any one-on-ones that get requested, and I'll be here in the main session answering questions as usual. So we'll see you in 2 to 3 minutes. Alrighty, folks. So, welcome back. I just wanted to check first before we do anything else. When we looked at this exercise, number 5, that we just went through with the sequelized library, were there any questions? All right. If we don't have any questions on this activity, then let's open it up more generally. Any things where you're like, I'm not sure about that, or any questions you might have about Sequelize or MVC or any of the other stuff we've covered this far?
So for for the API routes, they're just always referencing something in the HTML.
So for the API routes, these are always getting
Oh, yeah.
called by something in the HTML.
Yeah.
So
That's what I meant.
Yeah. So they don't have to necessarily be by the HTML. Like you could have a mobile app that's calling this as well, or another server could be potentially calling this. Like imagine someone else's project one that's leveraging your database of books, for example. So it's just a client is asking this. Now this API is designed specifically to work with the front end you are also building. So you want to make sure those two stay in sync. But you always want to keep track of what those expectations for your clients are. A lot of times, it's easier to change your front end than it is to change your API if you, for example, other people are using it. And so you try and organize your API to be act a certain way so that the front end, which will change more often, is a little bit easier to do that. And we're doing this in a very restful manner. Now, there's other ways of doing some of this stuff with APIs. If you wanted to look into some things after the class, GraphQL is a neat thing as a way to sort of, rather than calling a route and getting back a predefined list of, hey, this is what the object that you get back looks like, you can be a little bit more nuanced in the information that you want returned and customize it a little bit more. So that's GraphQL. And that's something you can look at, which I would encourage you to look at maybe after the course. There's enough kind of going on in the course to occupy your attention, I feel like.
So can you, if nobody has any other questions, can you just like, it's pretty clear when I look at it, but just kind of running through the, like looking at the HTML and saying, okay, here's each of these pieces and how they're interacting with
Sure.
each other.
So let's, our HTML is separated into a bunch of different ones. We're not doing server-side rendering in this case, which is why we don't have a views folder so much, because all that rendering is happening on the client. In fact, we're going to be doing a lot of that until React. You could still build these applications with server-side rendering, no problem. It's just that we're not in this case because we're focusing on models instead. So let's close everything out and then we'll open up the relevant pieces. I'm one of those people when you look at their web browser and they've got like 50 tabs open in like 3 different windows and everyone's like, how do you pay attention to that? And it's like, I don't, I just open a new tab when I need something.
Yeah.
So that happens with Visual Studio Code and me quite a bit as well. But we'll try and control the chaos. All right, so let's start out with all.html, which I believe will just show all of the books. So that's alt.html, which loads in alt.js. So the user hits the slash route, or not the slash route, the all route. they get sent back the all.html file. The all.html file makes a request to get the script, the all.js script, which gets loaded onto the page along with jQuery and some other stuff. Once it gets loaded onto the page, it makes an API request to API/all. So already, by the time we get here, this is our third request on the page, minimum. Even if we don't account for any of the CSS and different things. So there's the first one to get the HTML. Once the HTML is loaded, in addition to anything else it's asking for, like jQuery and the CDN, it's also requesting this locally from our server. And then this is making an API call. So this is this all.html making this API call. So we look at what matches this. Our HTML routes aren't going to match that. We look in our API routes and we find a route called API/all. And we go, cool. Book. Go ahead and find everything and then send that back. Now what the book does behind the scenes is it's connected to the books table, and it knows when you run find all, that's a select statement. And so it says select star from table, and it returns the result of that as a promise. And once that promise resolves, then we send that back to the front end here as data. Now, the data takes that and it's going to build some HTML with it. If we were to write this, and this one is a little bit more targeted in how it works because it's trying to find a specific section to inject all of that into. So the first thing it does is it makes a div, it adds some classes to it, it adds an ID to it, and then it appends that to the page, and then it injects the rest of this. Now, we could actually use the same techniques we were using with the server-side HTML here. We could actually make a function. Let's see, function create well section. And we'll pass in the data as props. And it's going to itself return a query string. And then we would just say well section.append, create well section for our data. And what would that look like? Well, it'd be a div. That div would have a class equal to well, and an ID equal to book-well-, and this is where we see our first little piece there, I. So maybe we need to pass in an index in there as well. And I'm just going to add that for the sake of ease. We could also just add it as a prop. Book well index. And then we would append the rest of these. So this would be in H2. We would say at the beginning, index +1. Oh, sorry, this should be create well data-I. And then I'll pull out const, what are we looking at? Title, author, genre, pages. Equals props, title, and then we've got H3 for all the others. And then we'll just pull all of these sections off. So let's refresh the page. Let's click on all books. And there it is. Heck, if we were being really creative, we could use map here. So let's actually do that real quick. So we'll say well section dot append data dot map book create well section. Actually, we need index here as well. And then we'll just join all of that together. And it might be me, but I feel like this is a little bit easier to follow. So all of those techniques that we learned for creating those views, you can still use them here. You'll just have to arrange them slightly differently. And the reason we do this is because those elements already exist, and we might actually set the HTML to just be that.
Definitely looks a lot. It's definitely a lot cleaner.
Yeah, I feel like it's easier to tell what's going on, and that's definitely a big improvement. Now, the issue and one of the reasons why we might not do this is because template strings aren't universal. And so you're going to see code that runs in the front end without any kind of preprocessor. If we look at caniuse.com, where we're not controlling the environment. Remember, with Node, we can control the environment. We know template strings works because we ran it and it worked. But if you're asking, can I use template strings? Then you're good as long as you're not trying to support IE11 or IE12 or really early versions of some of these other pieces. Now, 95.79% of all users, that's fine. And even to cover the rest of those, we'll look at something called polyfills or transpilers, which will allow you to translate your code to older versions. So for example, let's take this function. It's pure JavaScript, nothing special. There's no jQuery dependencies or anything in that. And we're going to go to a website called Babel.js. And what Babel does is it translates from newer versions of JavaScript to older versions of JavaScript. So it takes this and it turns it into this, so older browsers know how to do it. Now, do I want to program this? Am I going to maintain this and work with this? No, but I'm going to use this as kind of the output of this program so that we can show all of that different stuff. So that we can use these neat features, but we can still support all of these older browsers. You can see kind of the analogy. This line right here is broken up into all of these different pieces. This template string is broken up into all of this, concatenating all of it together. So this is what we like to call transpiling, which is taking stuff from earlier versions of or later versions of JavaScript and translating them into earlier equivalents so that we have browser support for older browsers. Things like that. And there's a file called Babel that'll do that for us. And we'll be using that later in the future, especially when we work with things that no browsers understand natively, like JSX, when we're programming React applications. But we'll mostly keep that under the hood. Most of the time, you don't need to dive too deep into what's going on there, but that's something to keep in mind as you're moving forward on that. Other questions? Any more questions? Any more? Need more questions?
Yeah, Eric.
Mm-hmm.
The homework that was due on Friday, and I think a lot of people had issues with it, and I think a lot of it was that a lot of code was provided. So for me personally, it threw me off. And this is one thing we were trying to go over yesterday, but we couldn't get it completed. But can you kind of go over, like, from A to Z? And definitely the index.js file, the code that was provided, that part in there, that's where I think my error was. So I wasn't really sure, but if you can just kind of go over that, I think I would appreciate it. I'm sure a lot of other people would too.
Was that the burger one?
No, it was the note taker.
The note taker. Cool. So this one?
Yes.
Cool.
Yeah.
Wait, no, is this the note taker? No, that's the MySQL one. The note taker was number 11. Yes. So which part were you running into specifically, Walter?
My part was, I could take a note, I could save it to the JSON file, but my list would not refresh. That new note would not populate, but it has been written to the JSON file.
Okay. So let's take a look at that. So if we want to visit our notes.html, there's a button for adding a new note. So that's under this section. We can see it's got a column. The text area has note text, and then we've got a note title. We're identifying those by these two pieces. And if we look at index.js in our front end, let's sort of take a look at what's happening there. So in our index.js, let's look for what happens when this thing gets submitted. So at the top level, before we do anything else, we're going to look for event handlers or click handlers. So I'm just going to minimize each one of these. We keep looking through, and we're not going to worry about looking through any of these until we arrive here on a click handler. So a note title here, we could, and there's, let's see, handle render save button. When we click on the save note button, is that hidden on here somewhere? Must just be in a slightly different part of the UI.
Yeah, it becomes, it's hidden by default and it like opens.
Yeah. Handle render save button. Yeah, handle note save. So save note button, if we look in our list of elements, is dot save note. So I'm going to look over here for a class equal to, or we'll just put save dash note. Cool. So when we click on that icon, then we'll handle the note save. So when we click on that button, first of all, you want to make sure that this event handler is set up where it listens for it. So let's go to handle note save. We've got a new note. This is going to be based off of the title and text in these two different areas. So that we're grabbing this one's, the notes title and the notes value, and then we're calling the save note function. And once that's done, we re-render. You could just refresh the page, or you could run Ajax commands to go and get that updated information. Either one is fine. So let's start out with save note. What happens in save note? Well, we're passing it an object with a title and text. And so this makes an Ajax request. The data, or the body of the request, is just those two fields that we saw earlier. That will have us land in the API routes, where we see router.post to notes. And then this is the store add note. That's, again, our database, which is actually just the file system. So we go to db store add note is just writing this out to the database. And then what it actually gives back to us is a list of all the new notes. It resolves that to be the new note that we wrote into the list. Now, we take that note that we got back and we send it to the front end. So it's been written into our DB at this point. Once we get back a response, db.json has been updated. So once save note has resolved, what do we do after that? Well, then we call get and render notes. So get and render notes is just a function that gets the notes and then passes that information off to a function called render note list. So you could almost copy and paste the body of that in there. So let's roll back to get notes. So get notes is an Ajax request that again goes back to our API routes. It hits /notes. It calls store.getNotes. Store.getNotes in this particular case, if we look at the store for get notes, what does this do? It reads things from the database and then concatenates everything together with an empty array and sends them back as the result of our promise. So once this resolves, being the parsed array of the contents, then our notes get sent to our front end, and then this promise resolves. And then those list of notes that we had in the render list get passed here. We empty that previous list, and then we just make new ones. So this is a function that we just created in line. That's to make new list items. So in this case, you can see, hey, here's the new list item. We're making it using jQuery. Here's the new span. We're making it using jQuery and setting the text. We're setting that into our list. And then if it should have a delete button, we add it there. And if it shouldn't, we just return it off. With delete button is by default set to true. So unless we explicitly say otherwise when we ask to create a new list item, it's not going to do any of that. Now, once we've got that helper function set up, if there's no notes, then just put in there a list item that says no saved notes. If there are notes, then go ahead and push in a list item for each one of those notes. And then finally, go ahead and take that new updated list and actually list of items and add it to our note list. Now, we can go over that again when we've got some more time. But we're getting towards the end of office hours at this point. But let's talk about the fundamental thing that you're going to do in any of these cases. And one of the reasons promises are so useful. Whenever you're doing any client-side rendering, you're going to have some, you need to get your data from somewhere. And most of the time that's going to be the server. So you have your browser. Your browser, somewhere in there is your first sort of event that happens is usually, it could be the page loads. It could be the user clicks on a button. There's something that kicks off this event. Usually you can look at that by either looking at what functions are called immediately or taking a look at your button or your click handlers. Usually those are on the top level of the file and not buried in a function anywhere. So you look for that. The next thing that you do is that this is going to result in some sort of call to the server. So the first one, you're looking for click handlers and function calls. One of those two. This next one, you're looking for AJAX requests. And especially if they're retrieving information, then you're going to be looking for GET requests. If they're creating new information, you're looking for POST requests. If you're updating, you're looking for put or patch, or deleting, you're looking for delete requests. So once you find the one that matches up with the event, you go on to the next circle. And it's not bad to actually just draw out what the pieces that you want. So our AJAX request then goes and is recognized by one of the handlers. So the next thing to do is find the route on the server. We'll kind of draw a big line in here between as the divide between the two. Everything on the right is happening on the server. Everything on the left is happening on the next piece here, or is happening on the browser. So our route handlers kick in. And in this case, the route handlers need to talk to some other pieces. They're going to be talking to the store, which is a database. So they say, okay, from here, or let's switch that color back to, I guess it was a red or something like that. Where do we go from here? Well, we're going to be talking to the database or the store or whatever is being used to hold our data, our model, for lack of a better term. Whether that's a file system, whether that's something just in memory, whatever's holding our data. If it's getting there, we know that it's at least asking for the data. And most of the time, you'll either get it directly or you'll have a promise that will resolve it for you. Then you're going to go back to your route handler because your route handler is going to tell you what happens with it, but 90% of the time it's using res.json to send that information back. So, which brings you back to the AJAX request, which will usually at that point, if either start handling the HTML directly or hand it off to some other function in the browser for it to use, usually one of those render functions. Now, those render functions might be kind of complicated. It might involve a lot of different things like, hey, we're going to build HTML. The things that you're going to want to pay attention to are what elements are being used that already exist on the page. And then what does the new items that I'm making look like? And you can just go through, follow each of the commands and say, okay, literally, what is it doing? And if it helps you to mimic it by making the HTML off to the side, that's a good one to look at as well. And then ultimately, once all that jQuery or anything else has finished, all of that makes its way back into the browser and you see it. So that's sort of the process I would go through whenever something's happening. You want to check at each one of these stages, is the thing that I want still happening? Hey, when I click on a route handler, is this resulting in a request to the server? Okay, the request to the server is working. Does it have all the information it needs? Is it getting the information out of the store properly? Is it passing it back to this request? Can I console.log out the result? Oh, okay. Am I building my HTML correctly based off of those results? Can I break it down and follow each one of the steps, even if they're a little bit difficult, maybe even hand making the HTML along the way to check my understanding or console.logging out different pieces, etc.
Yeah, and you said you were going to talk about promises and async and how it relates to this?
Yeah, most of these are chained together with promises. So if we look at, let's go ahead and clear all of this off. If you look at this, this is all working with the request response model, and within each one of those, there's promises on either side. So we start out with an event, and those are some pretty direct calls. So we look at, let's look at for Express. Let's start out with index.js for get notes. This is returning a promise. So whoever calls get notes can use .then. Let's go. And use that information. So in this case, render note list is taking those notes that get notes is promising and then rendering out the HTML based off of it. But there's quite a lot that happens before this promise resolves. Before this promise resolves, it has to do a couple of different things. So let's go back to get notes real quick. So this issues a request, response has to come back. How is that handled? That's handled in our server. Our API routes gets this request and it says, cool, I'll resolve that. I'll send back a response, thus resolving the first promise that I made. Once store.getNotes resolves its promises. So I'm going to say, okay, they made a promise. I'm going to get my notes, and these aren't the same get notes as out here. These happen to be named the same thing, but you can often tell what's in the browser and what's not because they can't cross-reference each other's functions. The only way that they can communicate is through this request response model. When someone does AJAX requests, that's how it's communicating. So the fact that we've got one labeled get notes here and one labeled get notes here is just a coincidence of naming. They're not directly calling each other. You could call one of them on the front end, what about a bing bong? And this one on the back end, some what about a bing bong? And the only thing wrong from the, and there wouldn't be anything wrong from the machine's perspective. It'd be completely okay with that. Your code reviewer might ask why you're calling things what about a bing bong? That would be the only issue. GetNotes happens to just be a good name for each. So store.getNote says, hey, well, I'm going to make you a promise that I'm going to get the notes from the store. Once I do, you can send this back to res.json, thus resolving, or send a response back to the front end, thus resolving that first promise and letting it render everything. So inside of this promise, if we look at it, and the store is defined in db store up here, what it's doing is saying to the file system, hey, read the notes from here. And once you have that, all the string that's created there, parse all of that information out of it. And then return that. Return me a list of all of the parsed information, and that'll be what I resolve this function with. So reads all of that information from the file system, resolves that promise. That promise then triggers this handler, which resolves the response. The response is sent back, resolving this promise, which then kicks off the then function associated with it, which in this case is this one, and it calls render note list with the information that was originally taken from that DB file. Now, do you need to break it into this many functions? No. In this particular case, they are just trying to show you how much you can isolate all of these different pieces, and the fact that they're all brought together can be a little tricky. So don't feel like you have to have written something exactly like the solution. They're kind of just showing you it broken up into the most different steps it could be.
All right, thank you, Eric.
All right. Cool. With that, it's 3:17, so it's been the end of office hours. So what I'm going to do is shut down the meeting at this point. If you have more questions, we'll be here bright and early at 9:15 for office hours tomorrow morning. If you have any questions about anything, or you need to set up one-on-ones or things like that, we'd love to talk to you then. For now, have a great evening. Tomorrow's Friday. Yay, excitement. We'll see you then.